Hi everyone, today I am going to discuss about how to calculate DFT for a given sequence. So n-point DFT for a given sequence. For example, the given sequence x of n is equal to 1, 2, 3, 4. 4-point sequence they have given. They asked to find 4-point DFT. 4-point DFT of the sequence. So we know the formula for DFT x of k equal to sigma as n, small n varies from 0 to capital N minus 1. N point DFT. K is DFT indication. Capital X is used for DFT. Small x is used for time domain signal. Capital X is used for frequency domain signal. That is DFT. Small x of n into Wn power kn. So this is the formula where Wn is e power minus j 2 pi by n. It is called twiddle factor. So where in the given formula n dimension n is equal to 4. So we'll substitute this in the formula x of k equal to small n equal to 0 to 4 minus 1 3 x of n into w, capital N is 4 power small k into small n. Okay, so in this formula n varies from 0 to n minus 1 and we will sum. Okay, but what about this k? So k is also varies from 0 to n minus 1. So we want to calculate x of 0, x of 1, x of 2, x of 3. 0 to n minus 1. N is 4, 4 minus 1, 3. So just we'll substitute in this formula n equal to 0 to 3, x of n, w4 power k, if you take 0, 0 into n. Okay, so this is sigma n equal to 0 to 3 x of n into w 4 power 0. So similarly, sigma when k equal to 1, n equal to 0 to 3 x of n w 4 power k is 1 into n. Okay, when n is k equal to 2, this is n equal to 0 to 3 x of n into w4 power 2 into n, and n equal to, this is x of 3 x of n into w4 power 3 into n. So we know the x of n in the given formula. Only thing is, if you know the w4 power some value, then we can substitute and we'll calculate the complete summation. Okay, so let's see the twiddle factor. What is twiddle factor? W. It has a property that periodicity and symmetricity property. We can easily calculate it. So W4, if n is equal to 4 means we want to calculate only two values, 4 by 2. W4 power, this power value will vary from 0 to 1. Okay, so we'll calculate only two powers when n is equal to 4. When n is equal to 8, we'll calculate only 4 values in the powers, that is 0 to 3. Okay, starting from 0 to n by 2 values we will calculate. So w4 power 0. w4 power 0 means, w4 means e power j 2 pi by 4 into whole power 0 means into 0. So e power 0 is what? 1. Similarly, w4 power 1 means e power minus j 2 pi by n is 4, whole power 1 means into 1. So which is equal to e power minus j pi by 2. E power minus j pi by 2 means cos 2 minus j sin pi by 2. Cos pi by 2 is 0. Sin pi by 2 is 1. So this is minus j. So if we calculate half number of twiddle factors, remaining can be easily calculated. How can we calculate the remaining powers means? Okay, remaining half, next half values, that is w 4 power 2 and w 4 power 3. Okay, 4 means 0 to power value will vary from 0 to n minus 1. That is 4 twiddle factors. If it is 4, 0 to 3 means 4 twiddle factors. In the 4 twiddle factor, first 2 will calculate, remaining 2 are negative of the first 2. w4 power 2 equal to minus w4 power. This is called symmetric property. If you take any n value, first half twiddle factors are repeated again in the negative sign for the next half twiddle factor. So this is w4 power 1 minus w4 power 1. So what is w4 power 0? 1. So minus 1. w4 power 3 is minus w4 power 1 minus of minus plus j. Okay. So now we will substitute these values in this expression. We will expand these expressions and we can calculate. So w4 power 0 is what here? 1. So 1 is nothing but sigma n equal to 0 to 3 x of n. Okay, just sum of all the samples in x of n. 1 plus 2 plus 3 plus 4. What is this expansion? When you substitute n equal to 0 to 3, x of 0 into w4 power 0, x of 1 w4 power 1 into n. 1 into 1 plus x of 2 into w4 power 1 into 2. Okay, plus x of 3 into w4 power 3. Okay, so we know x of 0 is 1, x of 1 is 2, 3, 4, and we know the twiddle factors w4 power 0, w4 power 1, w4 power 2, w4 power 3. We will substitute and we will simplify the real part and imaginary part. We will get a complex value. Similarly, here when you substitute k is equal to 2, this is w4 power 2n. We will expand n value, x of 0 into w4 power 0, x of 1 into w4 power 2 into 1. 2, n we are changing from 0 to 3, x of 2 into w4 power 2 into 2, 4, plus x of plus x of 3 into w4 power 2 into 3, 6. Okay, so just here we know the twiddle factors up to 0 to 3. If it is more than 3, okay, so if it is more than 3, more than n minus 1, n is 4, n minus 1 is 3. If it is n is 8, n minus 1 is 7. If it is more than n minus 1, just we'll calculate the value of the twiddle factor by using modulus operation. It's a very simple modulus operation. That is, for example, w4 power 6 we want to calculate. How can we calculate? Means this 6 will be divided by 4 and we'll take the remainder 6 by 4. Okay, remainder is 2. That remainder will be taken as the power value. So now we know w4 power 2 already we calculated. That is w minus w4 power 0. We can use this value. Similarly, if we get any higher power, we will just divide that power with n and we will take the remainder at the power. So that value will fall under first n values. Okay, so like this we can substitute the twiddle factors. If you calculate the twiddle factors, we can substitute here. Okay, thank you.